Hi everyone, welcome again. In this video, we are going to create a small Java project using Spring Boot, and here we will cover the overview of what we are going to do. So as I said, this is going to be a small project and it will focus on the hands-on. What we will do, we will create a main class, and from the main class we'll start the execution of the program. This main class will pass the control to a service, to a Spring Bean student service. Now this bean will pass the control to another bean, which will be student DAO in our case. And student DAO will have a connection with MySQL database. So when the application starts up, Spring Boot will call the main class. The main class will call a method of the student service bean. And from that method will call another method of student DAO. And then from that method of student DAO will fire a query, a read query to MySQL database, will read the data from the MySQL database and will do something with that data. Important thing to understand is what we are going to cover. Now we'll use Spring Core to configure Spring Beans and to auto-wire the dependencies of, let's say, student service and student DAO. Then we'll use Spring JDBC to create a bean of JDBC template. We'll use the JDBC template to talk to the database, and then we'll use Spring Boot to simplify everything. All right. So now that we understand, now that we have an overview of what we are going to do, let's make a start. How do we create a Spring Boot project? To do that, we'll use the Spring Initializer. Spring Initializer is a utility that helps us to generate a template project so that we can quickly start with things. And then we can build the actual project on top of that template project. To use the Spring Initializer, just Google Spring Initializer and go to this link, start.spring.io. Here you can see lots of details that we need to choose, like project, what kind of dependency management you want to use. So I'm going to select Maven, then Java is going to be my language. So we will be using the latest version, which is 3.1.1 as of now. Then comes the group, artifact, name and description, which basically goes to the pom.xml. So let me provide the details. Boot project, and you can change the description. It will be simple jar, and then we can choose the Java version. I'm going to use 17 because this is the LTS version, but you are free to use Java 20. Now comes the interesting part, because generally when we create a Maven project, we need to search for the Maven dependencies, but Spring Initializer simplifies this thing. So here, if you go to the add dependencies, then these are the main Spring dependencies that we can use in a project. So we don't have to Google everything. We can simply select the dependency from here, and Spring Initializer will create a template project according to that. Because we are going to create simple Spring Core project with Spring JDBC. So for Spring Core, we don't need to add anything. If we don't need any additional dependencies, Spring Boot by default creates a Spring Core project. The only thing that we need to do is we need to add the JDBC dependency, Spring JDBC dependency. So we can simply search for it. And here you can see this is the one that we need, Spring Data JDBC. So select this one, add dependency. And because MySQL is the backend data store for us, so we need to add the connector dependency as well. Here it is, MySQL JDBC driver. So let's add this one as well. And that's it. We don't need anything else. So we have the basic details and the dependencies that we need. Then we can simply generate the project by clicking the generate button. It will create the template project, and we have the zip downloaded on the system. So the next step is to extract the code base and to open it in IntelliJ. You can use Eclipse if you want. Here we have the zip folder. I'm going to extract it here in the same directory. Okay. And now, and from here I can do this to open it in IntelliJ. So this will now open the project using IntelliJ, and it will auto configure everything. trust the project. So we have a working project configured in IntelliJ, and if you see, this is syncing the project, downloading the Maven dependency and everything. So let's explore the project structure. Here we have SRC, and in SRC we have main folder. In main we have Java and resources. So Spring Initializer created an application.properties which is currently empty, but we can add the properties in this property file. Then it created a main class which is annotated with @Spring Boot application, and the main method is simply delegating the responsibility of running the application to Spring application, which is coming from the Spring library. And if we open the pom.xml, here we see that it has quite a few dependencies. First of all, the Spring Boot Maven plugin, which is required because we are using Spring Boot, and Spring Boot starter will handle all the dependencies. Then in the dependencies section, you see the MySQL connector J, which is the MySQL connector, and Spring Boot starter data JDBC. And Spring Boot has a starter POM for this one. So we can simply use this starter POM for Spring data JDBC so that Spring Boot can auto configure the project. Now notice that we are not specifying the version, and all these versions of dependencies will come from the Spring Boot starter parent, which is the parent kind of parent POM. There is a parent POM which would list down all the compatible versions of all these dependencies. So we just need to tell Spring Boot that I need this dependency, and everything else will be auto configured by Spring Boot. All right, we simply tell the Spring Boot what kind of project are we building, then we include the starter POM for that particular category, and Spring Boot guesses what kind of application are we trying to create. So it will see that we included starter POM for Spring Data JDBC, so it knows that we want to create a Spring JDBC project. So it will auto download some dependencies which are required for a Spring JDBC project, along with all the Spring Code dependencies. So we have all the dependencies that we need, and we can simply run the project. It is in the running condition. It won't do anything, but it will simply verify the setup. It is starting the application. And then if you say Spring Boot is bootstrapping the Spring Data JDBC repositories in default mode, we haven't told anything to Spring Boot, but because we included the starter data dependency in pom.xml, it knows that it's a Spring JDBC project. So it is auto configuring the project. Now, the next line says that found 0 JDBC repository interfaces, because right now this project is empty, so there is nothing. And then there is an error that we see that application failed to start, and the reason is failed to configure a data source. URL attribute is not specified and no embedded data source could be configured. Now we added the MySQL connector dependency, but we have not defined the actual data source, the URL, username, password that we generally provide to configure the data source. So, but one thing is certain, if you understand that Spring Boot is configuring the data source automatically just by looking at the dependency. So under the hood, Spring Boot does so many things. It tries to guess the kind of application that we want to create. And because we have not provided anything as of now, it failed to create the data source bean, and so the overall application failed. So now we'll start adding the missing pieces in this application. So how do we fix it? Before fixing this, let's take a step back and try to understand how we generally create data source without using Spring Boot. So I have another project in which I'm not using Spring Boot. So here, as you can see, without Spring Boot, what we generally do, we create a configuration file and annotate that file with @configuration annotation. And in that configuration file, we create @bean methods to create new beans. So here we created a new method to tell Spring that this will create a new bean. And then in this method, we are creating a new data source bean, driver manager data source, by setting all the properties. So driver class name, username, password, and the URL. That's how we create the data source when we are not using Spring Boot. But Spring Boot simplifies everything. Spring Boot just needs to know about the database details and it will create the data source automatically. And that's what it is doing here. So if you notice, it was trying to create the data source, but it could not find the details. So all we need to do is we need to provide the details to Spring Boot. And to do that, we will use application.properties. So we simply need to provide the details using this application properties. Spring Boot will automatically read the values from the application properties and it will initialize or configure the project accordingly. So in this case, if we provide the correct details of database, it will create the data source on its own. So let's do that. The properties that we need to provide are spring.datasource.username, which is root in our case, then spring.datasource.password, my root password because I'm using MySQL database, then spring.datasource.url. So that is going to be my Spring JDBC, which is an existing database running on my local. So that's all we need to do. We are providing the database URL where Spring Boot will find the database, then username and password. Let's try it again. And this time, if we run the code base, we see that it ran fine. It successfully created or started the JDBC related configurations, the pool and everything. And then it started the application and exited the application gracefully because there is nothing else that we are doing in the main class. So we are simply delegating the responsibility to Spring Boot and that's it. So we don't see any error on the console. That means the setup is working fine. So we successfully created the data source by providing these properties to Spring Boot. Let's move on. Now let's add more details to this project. So when the application starts up, which means when we run the main program, what we need to do, we need to call a service. So that service will actually trigger the execution of the flow of this program. And that service then will call a DAO and DAO will fetch the data from the database. So that's what we want to achieve using Spring Boot. It's a simple flow. It's a very simple application. So to do that, we need to create a new service. So first of all, let's create a new package. Then in this package, we'll create a new service and we name it, let's say, student service. Okay. This service will then call a DAO. So we need a DAO and we'll add another package to store the DAO classes. And we'll have a single DAO, student DAO. Okay. Now that we have these classes, we simply need to configure them so that Spring can understand these classes and then we need to wire them. Now that we have the required classes, we need to configure them as Spring Beans. To make them discoverable by Spring Container or the Spring's IOC container, we need to annotate them. Now this class will play the role of service, so we can annotate it with @service annotation. We can also annotate it with @component, but because the role of this class is to play the service, so it is better to tag it with @service annotation. Coming to the DAO, this is DAO, and the responsibility of DAO class is to talk to the database, and such classes are annotated with @repository annotation. like this. We created two beans and annotated them with @service and @repository. The next step is how to register these beans with Spring's application context. So if we again go back to the old project without Spring Boot, here we see we created the config file, then we added @component scan and provided a package path. And the component scan is used by the Spring container to scan the package that we provide here, and all the sub packages to find the Spring beans or all the classes annotated with Spring annotations. And that's how Spring container knows what all classes it has to scan. All right, otherwise it doesn't know how to scan the classes. So just annotating them with @component or @repository or @service is not sufficient. We need to add the component scan as well. We need to provide this information to Spring's IOC container. But the good thing is when we use Spring Boot, we don't need to create a config file like this, or we don't need to add this component scan explicitly. Spring Boot does it automatically. So if we go back to the main class, we see that the main class, this one, has a special annotation @Spring Boot application. And if we open the Spring Boot application here, we see that it has this @component scan. So this @Spring Boot application is a special annotation. It is, you can say, a collection of annotations. And one of them is component scan. So when we annotate the main class with @Spring Boot application, it automatically does the component scan. What it does, it considers this package as the root package. That means because this class is annotated with @Spring Boot application, what Spring will do, it will start scanning the classes from this package, and it will cover all the sub packages. So this becomes the root package for the component scan. And that also means that we don't need to explicitly write @component scan annotation. It is automatically handled by the Spring Boot. Now coming back to the application, since we have already annotated the classes student service and student DAO, all we need to do is we can simply run the application because component scan is already handled by the Spring Boot. So let's give it a try. Let's run it and see what happens. So here we see everything just worked fine, same as before. We don't see any error. We don't see anything happening as well, but we don't see any error. That means Spring successfully passed the annotations and registered the beans. Okay, moving on. The next step is to wire these classes together. When we start the execution from the main class, the program will start its execution from the main method, and from the main method we will pass the control to student service, and from the student service we'll pass the control to student DAO, which will fetch the data from the database. So we need to inject student DAO in the student service so that the service can talk to DAO class. To do that, we'll say student DAO and we'll auto wire the dependency like this. When we do this, this dependency will be injected and wired by the Spring container automatically. So student service will have a valid instance or a valid reference of student DAO. Let's write a method as well. Public void fetch student, and we can say student DAO dot, because right now there is no method in student DAO, so let's say something like read student from DB, and we'll create this method in the student DAO like this. So when we call the fetch student method of student service, it internally will call the read student from DB method of student DAO. And now we need to provide the implementation of read student from the database. This method will have the implementation to talk to the database, which is our next step. So we'll go back to the old project again, this one. And if we go back to the student DAO, here we see that we need the data source. So what we did, we auto-wired the data source dependency, and then we created the JDBC template by calling the constructor in the student DAO. And we had to do this in this way because we were not using Spring Boot. But the good thing about Spring Boot is once we provide the data source details in the application properties like this, what Spring Boot will do by reading this configuration, it will not only create the data source, but it will also create the JDBC template. So we don't need to create the JDBC template manually. All we need to do is we can directly auto-wire or inject the JDBC template in the DAO where we need it. So we can simply inject the JDBC template in the DAO class. We simply need to auto-wire it like this. What we did, let's go back. What we did, we provided the data source configuration in the application properties file, and Spring Boot will create data source and JDBC template automatically. And because we are auto wiring the JDBC template in the student DAO, so Spring will inject the valid reference of JDBC template in the student DAO. Now, before we trigger a select query from the code, let's make sure that the database is running. So let me start my database. I need to start my MySQL server. And then I'll start the workbench. Okay, so let's open the SQL editor, and this is the database that we are using. Let me confirm once again. So in the properties file, we have provided or passed this database spring-jdbc, and that's the one we are looking at. And in this one, we have a table student. So let's see the data. We have 3 records. So let's write the code to read one of the records from the student DAO. All right. So in the student DAO, we have the JDBC template. We can then use this JDBC template to select some data, to read some data from the database. To do that, we'll use the query method, and we'll write the query select star from students where id equals to this one. And we need to pass the id. Here, let's pass the id 2 like this. And instead of query, let's use query for map, because we are selecting all the columns. So query for map can return all the values for all the columns. Okay. And it will return a map of string and object like this. And we can simply get it printed like this. So what we did, we auto-wired the JDBC template. Then we used query for map method to fire this query. We are basically passing the id 2, and we are saying, give me all the details from the student table where id is 2. Now that we have all the code ready, all we need to do is we need to trigger the execution of this program from the main method. How do we do that? Because right now, if we run the main method, it won't do anything. It will simply run the basic flow. And because we're not doing anything additional in the main method, we don't see anything happening in the logs. So you see there is no information related to what we did in the student DAO because we are not calling it. So the next thing is, how do we trigger everything from the main method, so that from the main method we can call student service, and the service can make a call to student DAO, which will read data from the database. Now, before we do that, let's go back to the old project again in order to better understand the differences. So if you go to the runner class here, we see that when we don't use the Spring Boot, what we did, we initialized the application context using annotation config application context manually. Then what we did, we got the reference from the application context and called the method. But here if we see, we have no access to the application context, but still everything is running fine because this is a Spring Boot application. So Spring Boot automatically initializes the application context based on the information it has. So it automatically initialized the application context. We can access this context, get the instance of student service, and call this method to initialize the flow or to start the flow. To do that, what we do, we implement the command line runner. There is a special class that we use. So like this, application context, and then we'll say return args, and it must be annotated with @bean. So the thing is, if we want to access the application context from the main class, what we need to do is we need to create a bean. So we need to write a method, annotate it with @bean annotation, and it's an indication to Spring Boot that this method will create and return a bean of type command line runner. Okay, and because in this method we are passing application context, so what Spring Boot will do at runtime, it will inject the dependency of application context, which has been already initialized, to this method so that we can create and return an instance of command line runner. And this bean is used by Spring Boot internally when it's running this run method. So before it completes the execution of run method, it will call the command line runner, and whatever implementation we give in this method here will be executed by the Spring Boot before it completes the execution of this run method. So here we already have the access to application context. So what we can do, we can use this application context to get the instance of student service like this .get bean, and once we have the object of student service, we can call the method of this service fetch student. And this time if we run the program, we see everything worked fine, there are no errors, and if you notice, we got the output here. So this is the output of query for map method. So what happens when we run this program, Spring Boot will start running the main method, and from the main method it will start executing this run method, spring application.run method. And before it completes the execution of run method, it will notice that there is this bean command line runner that we are using. So it will execute the code given in this command line runner bean, which is basically this. So what it did, it executed this code. All right. It got the instance of student service from the application context because code has access to this application context. And then we are calling the fetch student method. So it will execute this code. It will call the student DAO and this method. And in this method, we are using JDBC template to read the data from the database. And once we have the map, which was returned by query for map method, and we are printing this result, That's what we see in the console. So we successfully created a small Spring Boot application. Although it was a simple application, but we saw how to use Spring Core in a Spring Boot application and how to use Spring JDBC to talk to the database using JDBC template. So that's it for now. Hope this small application will give you enough start with Spring Boot, and we'll see you soon in the future videos. Thanks for watching.